Now let's dive into the VPC module. This is where all the networking logic lives. The first thing the module does is discover available AZs dynamically. Instead of hard-coding AZ names, we query AWS. This makes the code portable. Deploy to US-East-1, and it automatically finds US-East-1A and US-East-1B. Deploy to EU-East-1, and it finds the European AZs. No changes needed. Next, the VPC itself. The CIDR 10.20.0.0/16 is the private address space. The DNS settings let instances resolve DNS names, which is essential for modern applications. All resources get a name tag for easy identification in the console. The Internet Gateway is straightforward. It attaches to the VPC. That's it. We don't configure it further. Just the existence of this resource and the attachment enables the public subnets to route to the internet. Now, the public subnets. This is where we use powerful Terraform features for each to avoid repetition. What's happening here is we loop over the public subnet CIDRs list to 2 CIDRs and create 1 subnet per item. The key insight is map public IP on launch equals true. Every instance launched in this subnet automatically gets a public IP. That's what makes it public. We also distribute across AZs. The first subnet goes to US-East-2A. The second goes to US-East-2B. This gives us availability. If one AZ goes down, the other still works. Private subnets are identical, except no public IP mapping. No map public IP on launch, so instances here are private by default. They'll need the NAT gateway for outbound internet access. The NAT gateway requires 2 things, an elastic IP and the gateway itself. The elastic IP is a static public address assigned to the NAT gateway. The NAT gateway is placed in the first public subnet. It needs a public IP and internet access to do its job. The depends on assures the internet gateway is created first. Route tables are traffic directors. The public route table, as shown here, the route says any traffic going to 0.0.0.0/0 goes to the internet gateway. The association link both public subnets to this table. The private route table is almost identical, except the route points to the NAT gateway, so private instances send outbound traffic through the NAT, not directly to the internet gateway. That's the security boundary. Finally, the VPC module outputs 3 things. The root main.tf uses these outputs, especially the subnet IDs, to place the EC2 instance in the right location.